Thank you for that presentation. Next, I'd like to invite Micheal Boot, founder and co-CEO of Vertoro, to present Lignin, one carbon platform for multiple climate verticals. Welcome on stage.
First, by a show of hands, who of you have never heard of the word lignin before just now? Well, you're in for a treat. So we'll start with some evolutionary biology, just so the next time somebody asks you this question, you'll have the answer. If we look at aquatic biomass like seaweeds, and then we compare those to terrestrial biomass like trees, the main compositional difference between the two is lignin. But then you still don't know what lignin is. So why did lignin evolve? When these first brave seaweeds ventured onto land some 300 million years ago, they encountered a host of new evolutionary pressures, like oxygen, like gravity, like oxygen, UV, fire, microbes. The cellulose, which is the main component of seaweeds, were completely unprotected against these new pressures. So nature evolved lignin as a sort of a protective shield. But not just a protective shield, also a scaffolding mechanism so plants could grow and compete for sunlight. So I always like to compare a tree to reinforced concrete, with cellulose being the beams and lignin being the cement. So for 2,000 years, we've been valorizing the cellulose into paper, dumping lignin into rivers or burning it in boilers. So today we'll be exploring what we could actually do with that lignin. First, have a look at these photos of terrestrial biomass, or agricultural residues and forestry residues. Look for some common denominators there. And then freeze those in your mind as we transition to fossil world infrastructure, so the trillions we have invested today in fossil world legacy assets. And not just the legacy assets, also all of the ships, all of the planes have something in common with those legacy assets as well. The way I try to explain it to my kids is the problem that we're facing trying to get that biomass into those legacy assets and into the ships and airplanes is a fundamental one. So it's like trying to squeeze a square peg into a round hole. The problem with the biomass, it's a solid. And everything in existing fossil world infrastructure and everything going into the jets as a fuel or into the ships as a fuel is a liquid. So we need to solve that problem. And there's two ways you can solve that problem. You can solve the problem how I solved it when I was about 2-3 years old, just smashing the square block into the round hole until it went through, irredeemably damaging the square never to be a square again. Or what I'll take you through today is our approach as Vertoro. It's a reversible approach, so we can take the solid biomass, turn it into a liquid state, and then go back to a solid state for other types of applications than just fuel. So how did we get there? We got there looking at the lowly coffee bean. Coffee bean is a very special type of biomass. And the way we turned the coffee bean into a liquid has actually been something at TRL9 for several hundreds of years already. We simply cook it in a solvent, then part of the coffee bean is solubilized in the solvent, and that blend we call coffee. Of course, when we look at biomass and lignin in particular, we have to do something slightly different. A tree is not a coffee bean, corn stover is not a coffee bean. So we can't use water as a solvent. We have to use alcohols, methanol or ethanol, as a solvent. And the 90 degrees that we use for coffee just won't cut it. So we need slightly elevated temperatures around 180 or so. But that's about it. And the reason I put the patent families there is just to emphasize that something doesn't have to be needlessly complex or sophisticated in order to be innovative and patentable. When we put a tree into our coffee machine, cook it in an alcohol, then the lignin part of that tree solubilizes in the alcohol, creating a blend of alcohol plus lignin. That's our coffee, which in the part that's in the waste compartment of our coffee machine is cellulose. And cellulose, as I mentioned before, we have no shortage of uses for cellulose. We can do lots of things. Looking for market applications for our alcohol lignin blend, which is a strange beast, we first turned to markets that already pivoted away from heavy petroleum products and invested lots of money to pivot towards alcohols as fuels. So this is a non-exhaustive list of shipping companies that each have invested billions in order to buy vessels that can sail on methanol or ethanol. And it's not just shipping companies that have invested to move away from petroleum products to alcohols, also oil companies. Petrobras leading the pack, Exxon in the US, and others in their wake, looking at ethanol specifically as a feedstock for oil refinery co-processing to make ethylene, and then the ethylene goes to SAF or to plastics. So our pitch to these companies has been, if you like water, you'll love our coffee. So it has certain performance benefits to feed in not only the alcohol, but also some lignin inside. For the engines, it's optimized performance, so better ignitability of the fuel, higher energy density of the fuel. For oil refiners, it means when you put in the alcohol, you only get ethylene. When you put in the alcohol and lignin, you get ethylene, and you get very valuable aromatics as well, also some that are in the jet fuel range. But I mentioned at the start, reversible. Making coffee is also a reversible process. Also been at TRL9 for about 100 years. Instant coffee. Now, how do we go from coffee to instant coffee? It's as easy as leaving your cup on your desk before you went to this conference. All it is simple evaporations. And for us, it's the same. When we take our lignin alcohol blends and evaporate out the alcohol, what is left is a highly purified form of lignin. And on one of the first slides, I explained what lignin is. It's an antioxidant, it's a UV blocker, it's an antimicrobial agent, it's a natural resin, and much more. So for our lignin product that we branded Goldilocks, we're developing applications as diverse as engineering plastics and personal care. So my favorite toys as a kid were things that were two things, like a transformer was a robot and it was a truck. Or my favorite clothes were those that were reversible. It was a blue shirt and then you switched it around and it was a white shirt. So too with this product. It's the only fuel on the market that is also an antioxidant, it's also an engineering plastic and all these things. By the same token, it's the only engineering plastic that's also a fuel. So my childhood passion of things being two or more applications at the same time has turned into a true business model. We'll be closing our B round, first close, within the next couple of weeks. We'll be considering a second close with select investors, and then 18 to 24 months from now, we'll go into our next investment round for the actual CapEx investment for a first-of-a-kind plant. Thank you for your attention.